last thing we did last time is how to find the variance and how to find your standard deviation. Okay, so now this is where we stop in terms of the material, which is now we have this unique histogram, which is a symmetric histogram. So this is, you know, ideally this is our data. When you collect the data, ideally it won't be this ideal, but again, we want our data to be a bell-shaped curve, or later on you will see that this is a normally distributed, meaning again it's very much the mean, the median, and mode is at the center of this thing here, and we have 50% of data below and 15% of data above. But for now, just know that this, we call this a bell-shaped curve, is basically symmetric. Okay, so now looking at this thing here with the bell-shaped curve, this is what we have, is we have a rule to look in for in terms that an empirical rule, right? So again, empirical rule is this, ladies and gentlemen. Empirical rule is basically tell you that if you have empirical rule, or in terms that if you have a bell-shaped curve, within one standard deviation, think about this thing here, which is your mean is the center. Your mean is at the center. Your mean is at the center of this item right here. And within one standard deviation is basically tell you that if you take one step to the left and one step to the right within one standard deviation. So you will hear me say that within one standard deviation, meaning how many steps we have to take. So if we take one step to the left and one step to the right, that will consider 68% of your data. Pretty much, as you can see, the highest peak of my graph is right here. And the ideally, or a lot of things is, most of the data you have will be tentatively cluttered around the center, around the mean. So as you can see, the further away from the mean, the smaller the graph will be, right? As you can see, it starts to decrease, meaning the area under the graph right here will be less and less and less and less. That's why the percentage will be smaller, as we will go outward. Okay, so this is what they tell you is within one standard deviation, meaning if you take one step to the left and one step to the right, it will be 68% of your data. So imagine if I have 100 people in my class and we took the test, right? 68% of them will be within one step away from the mean. Okay, within one standard deviation away from the mean, that will be 68 out of the 100 people will make the score in that group. And again, if we take two steps, if we have two standard deviation, that will consider 95% of your data. 95 people, if I have 100 people, 95 of them will be within two standard deviation from the mean, meaning you have to take two steps to the right and two steps to the left. That will consider 95% of your data. And for now, we say almost all of your data will be within 3 standard deviation from your mean, meaning we take 3 steps above and 3 steps below. That will be almost all. Later on, when we get to chapter 6, they change this almost all to be 99.7%. Okay, 99.7%, that's pretty much very close to 100%. That's why it's almost all. So looking at this thing here, this is the empirical rule. And one thing about the empirical rule is very restricted, ladies and gentlemen. Is have to be first, the data have to be a bell-shaped curve. If it's not a bell-shaped curve, we cannot imply using empirical rule. And secondly, the empirical rule can only state that within 1 standard deviation, within 2 standard deviation, and within 3 standard deviation. It cannot be 0.5 or 1.5. For now, we don't know. As you can see, they are not, that's the measure in terms that is not half of 34 on this side or that items, right? Because this thing starts decreasing, so we cannot just go a half of the step. We cannot go to 1.5 of the step. We have to go in 1 standard deviation, 2 standard deviation, and 3 standard deviation. So again, that's the empirical rule, and it's very restricted. It's got to be, have to be a bell-shaped curve, and it's have to be within 1, within 2, and within 3. Okay. So with that, now this is what they ask you to do is now with that information, with this rule, we have to apply that rule and kind of manipulate our way to find the answer to the question, right? So this is what they give us is, again, given the following data for the population, right? And reminder, the mu, this u, kind of looking u, is your mu, which is your population mean, which is 18. And the standard deviation, which is the sigma, is equal to 9. So we know that the mu, which is the middle of your bell-shaped curve, if we have a bell-shaped curve, and the standard deviation, which is, again, the spread, the average of spreading out of your data, is 9 units, right? So this is what they tell you is, assume that the population is a bell-shaped curve, and you need to have that, ladies and gentlemen. If they don't mention anything about bell-shaped curve, you cannot assume it's a bell-shaped curve. They have to mention it. Okay, if it's not a bell-shaped curve, we cannot use the empirical rule. Empirical rule can only apply to a bell-shaped curve. Okay, between what two value will approximately 68% of my data. So we know that we have 68% of data is within one standard deviation. The question asking you is now, what will be my unit that will cover that 68% of the data, right? So, you know, what data can I use here? I don't have the data. I just make up number. So in my previous section, I use this as the weight of the baby, the infant, like 6-month-old baby, but it's not gonna be realistic if it's have a negative units into it. But anyway, let's take a look at this thing here. We know that 68% is within one standard deviation. Meaning, again, within one standard deviation, meaning we take one step to the left from the mean, which is from the middle of my graph, and one step to the right, okay? And that's within one standard deviation. So if you look at this thing here, this is what they tell you is, again, like I mentioned, if we take to the left, if you look at this formula here, they basically tell you that if you take one step to the left, all you need to do is take the mean minus the standard deviation here. And if you take one step to the right, you take the mean and add it to the standard deviation here to find your actual unit, okay? So looking at this thing here, if we know that this is my mean, which is my center is 18, and all I need to do is add 9, everybody see that my upper unit is 27, and vice versa. If I go to the left, I have to take 18 minus 9, which is my lower limit is 9. So given that, everybody see that between the two units is 9 and 27. Those are the two units that cover 68% of my data. Okay, and again, you probably say, wait a minute, Mr. Strand, I'm confused in terms of what is this standard deviation versus within one standard deviation. So whenever you read and they say within one standard deviation, just think in terms that is the steps that you need to take away from your mean. But each step you take, you have to add the actual unit. This standard deviation right here is the actual unit that we find last time. Is the actual data, the data unit that we have. Within one standard deviation, meaning the step that we need to take from the mean, okay? And later on, we will say that they change and did within one standard deviation to become a z-score, which is that in 3.3. But again, question on how I get the 9 as my lower point and 27 as my upper value. The other question that they ask you is, instead of find the actual unit, they ask you, well, what if I have the unit and I want you to tell me how much is the percentage of my data, how much percentage contain between these two units, right? So they ask you this, which is assume that the population is a bell-shaped curve. And again, bell-shaped curve is basically tell you it's symmetric, is you can use empirical rule. That's like a green light for you to use empirical rule, okay? Approximately what percentage of the population value are between -9 and 45? So looking at this thing here, we basically, again, you have to ask yourself, like I mentioned, if we go here, we subtract 9, right? From 18, we subtract 9 to get 9. From 9, we subtract 9 to get 0. And from 0, we subtract 9. Everybody see that my lower value is -9. This is where I have. And similarly, if I have 18, I add 9, I add 9, I add 9, I have 45, which is everybody see that in this case, this is what we have is from the middle, from the mean, I take 3 steps to give me -9 to the left. And from the mean, which is 18, I take 3 steps, which is I added 9, add 9, add 9 to give me 45, which is my upper value, which is everybody see that because I took 3 steps to the left and 3 steps to the right, is cover almost all of my data. Okay, for now we use the word almost all because it's within 3 standard deviation. And again, within 3 standard deviation, meaning you take 3 steps. But each step you take, you have to add the actual units of 9 units in it or subtract 9 units in it. Question here in terms of how to find the value if they give you the percentage or vice versa. How to find the percentage if they give you the value. If somebody did the ANOVA notation? Did somebody draw the highlight item?
No.
And question here between question with A or B here. All right, if you don't have question, let's take a look at the next example. And again, the next example I have here, which is hopefully a little bit, if hopefully it's clear out a little bit in terms of the item here. Similarly, I instead of give you the population, I give you the sample, right? And reminder the sample is your X bar for your mean and the sigma, not the sigma, the S for your sample standard deviation. So same idea here, which is I give you the mean, which is reminder the mean is the middle of your empirical rule, right? The center of your empirical rule, that's your mean, right? So assume that the sample is a bell-shaped curve, and like I mentioned, the bell shape is basically tell you that's the green light that we need to use the empirical rule, right? Between what two value will approximately 90% of the sample would be, right? So looking at this thing here, we look at this thing here, and again, disregard this symbol, right? This is the, I use the same picture. Is this thing supposed to be the X bar and this thing supposed to be S? But looking at this thing here, we know that if we have the center at 150, 153, each time we move 1 step, we have to add the actual 17 units, right? So looking at this thing here, we know that we have to take 2 steps to the left and 2 steps to the right to consider 95% of my data. Agree? So looking at that there, which is again, looking at this thing here, we know that the within 2 standard deviation, which is, this is what I have is, instead of add 17 and add another 17, all I need to do is I take the 2 standard deviation with this and multiply to my actual standard deviation to give me 34. Everybody see that? Which is, again, looking at this thing here, all I need to do is take 153, add it to 34, because again, 17 and another 17, that's 34, to give me the upper unit at 187, and vice versa to the left, instead of add, I need to subtract to give me the lower limit at 119. Meaning, looking at this thing here, I know that between the 2 values, between the 119 and the 187, those are the 2 values that cover 95% of my data, right? Or in another word, like I have this illustration. If you print it out, if you print this thing out on your item, I have this illustration in terms that, again, if you take 1 step, we start in the middle. Excuse me. We start in the middle, which is my mean. My mean is 153. If I take 1 step, I need to add 17. That will give me 170. And if I take another step, that will give me 187. That's, as you can see, that is my upper value. And vice versa, if I take the step to the left, I need to subtract 17. And again, if I take another step to subtract 17 again, because of the 95%, it has to be within 2 standard deviation, and within 2 standard deviation, meaning we have to take 2 steps to the left and 2 steps to the right. And everybody see that my lower limit of lower value is 119 and the upper value is 187. So question here in terms of how I get this 2 value using either this formula, as you will see later, you will have to use this formula, or using this figure here. And the other question is, if they give you the value, now they ask you what is the percentage, right? What is the percentage of this thing here? Assume that the sample is a bell-shaped curve, and again, that's your green light that we have to use a bell-shaped curve. What percentage of the sample value between 136 and 170? So if you look at my diagram or figure here, we can see that 136 is right here and 170 is right here, which is everybody see that that will give me, or that approximately 68% of my sample, right? Which is, again, this is the 2 value we have, which is basically you ask yourself, if you don't have this figure, you know, empirical rule is very easy, ladies and gentlemen. You have only 3 steps, right? And every time you take 1 step, you have to add whatever the unit is. So if on your homework, if they give you this, you can have something like this and say, okay, the meter, let's say the mean is 10 and the standard deviation is 2, then you say, okay, my meter is 10, then I have 12, 14, 16, right? I subtract, I have 8, 6, and 4. So you can list all those numbers out and then just go and see what the question asks you, right? Which is, again, that is the idea of empirical rule, and it's always by 1, by 2, and by 3. Empirical rule doesn't have anything in between. It's only 1 whole step to the left, to the right, to the left, to the right 2, and to the left and to the right 3. So question with this empirical rule, and again, hopefully someone have a question in beginning of class. Hopefully I answer the question. If not, do you still have any question with this empirical rule here? All right.
Okay, thank you.
All right. If you don't have question, empirical rule, and ladies and gentlemen, like I mentioned, in order for you to use empirical rule, your data have to be symmetric bell shape. What happens if your data is not a bell shape? If you're, like I mentioned earlier, if your data is not a bell-shaped curve, we cannot use empirical rule. Now, if your data is not a bell shape, we have to use this inequality, which is a Chebyshev inequality, right? So the Chebyshev inequality tell you this, which is if you have any data, even if it's a bell shape, it's just that bell shape is easier to use empirical, right? Even if your data is not a bell shape, right? Or even if your data is a bell shape, or in terms of Chebyshev is basically this, is any data set you have, it can be symmetric, it can be skewed to the left, skewed to the right, or scattered like this, right? To find the percentage of your data, we have to plug into this formula, which is the percentage, or approximately 1 minus 1 over k squared. And the k here is the steps that we need to take. Remember, within, everybody see within, last time within 1 standard deviation, meaning again, we step 1 to the left, 1 to the right. Within 2, now instead of the number, they say within k standard deviation. But the k that we will be using most likely will be k is equal to 2 or k is equal to 3, right? You can do k equal to decimal, it's just that you will get a decimal. You will not have a k equal to 1, ladies and gentlemen, because k equal to 1, everybody see that k equal to 1, k is 1, 1 square will give you 1, 1 over 1 is 1, which is 1 minus 1 will give you 0, meaning within 1 standard deviation, if your data is scattered out, within 1 standard deviation, the mean will be 0% of your data. We don't know. We don't know how much because it's scattered. Sometimes the standard deviation is somewhere here and all of your data is on the 2 sides. Okay, but this is what we have is if the k is equal to 2, And if the, basically this is all you need to remember for the Chebyshev inequality is if the k is equal to 2, it will consider 75% of your data. Meaning within 2 standard deviation, for the Chebyshev, within 2 standard deviation, it will consider 75% of your data. Vice versa, within 3 standard deviation, for the Chebyshev, it will consider 88.9% of your data. That's the difference between the Chebyshev versus the empirical rule. Because empirical rule, we assume that all of your data is closer to the mean, so that it's more percentage around the mean. The Chebyshev, your data is scattered out. So pretty much they say we don't care what kind of set we have, what kind of data we have. We can guesstimate, or we can find the approximate of the percentage. And that's what the Chebyshev come in place, okay? So basically Chebyshev, 2 number, K2 is equal to 75%, K is 3 is equal to 88.9%, okay? So let's take a look at this thing here, which is let's apply what we just know to our problem. So they tell you this thing here, which is given the following data for the sample, the mean is equal to 79, and the standard deviation S is equal to 7. So we deal with a sample. At least what percentage of the data? So let me ask you, when you do your homework, as you can see, hopefully you say, wait a minute,